All right, good evening, students. All right, so let's begin with our new topic, which is maximum demand. Anyone know what maximum demand is from your experience or from your previous courses? Does it ring any bell, or is it the first time you are seeing this term? Most likely first time, right? So what is maximum demand? The name already suggests maximum, and then the second word is demand. So something to do with demand is basically the power, right, that you demand from the utility supplier or the EFL, for example. Maximum is the maximum that you need, okay, to maybe use electrical equipments or your household appliances and so forth. So it is given here as a electrical demand. Okay, maximum demand is basically the electrical demand. In Fiji, we get bills, right, for per month. So for a month, the maximum demand is also monitored for a month, and we'll look later on what specific time period is looked at within this month period, right. The measurement of the MD is kilowatt, and then maximum demand is the peak load imposed by the customer to the electricity company at any point in time, right, just as I have said a while ago. Okay, so it is the peak load, okay, and the company, which is EFL in our case in Fiji, it has to cater for this maximum demand or the peak load which is required by the customer. Okay, now the electricity cannot be stored. Okay, we can see that the electricity is generated as soon as it is required, right? It is not stored. So that's why there must be sufficient generation available, to meet this highest demand capacity, right? And also the maximum demand tariffs also apply. That doesn't mean you have maximum demand or require peak load to be supplied by a customer and do not pay the price. So if you are consuming that peak load, okay, require that much as a customer, if you require that much supply from the EFL, then you should be ready to pay as well, because the maximum demand tariffs are higher than the normal usage. Maybe you guys can find out in your own time on EFL website. They must have the maximum demand tariffs. Okay, they will have a load range. If you consume between those ranges, then the tariff will be higher, and then there are levels. Okay, so as the maximum demand goes up, the tariffs also increase. So that is the main reason for that, is to discourage consumers from needing that much or consuming that much kilowatts, right. The main reason is because we have to generate the electricity as it is demanded. So, and it cannot be stored, like we can generate more now and then supply it later. It doesn't happen that way. So the tariffs are in place so that to encourage the customers to control their electricity demand peaks, right, and not to use electricity unnecessarily. Now let's look at a simple example. Okay, let's say if a house uses the following appliances per day, calculate its units and the bill for a month. So we have 4 9-watt LED bulb which runs for 10 hours, and this is for 1 day, right? Yeah, per day. So in 1 day, 10 hours, 4 LEDs are on, And there are two 60-watt fans which are on for 16 hours. One TV rated 100 watts, it is on for 5 hours. And a refrigerator which is 200 watts. And then refrigerator always have duty cycle, okay, because compressor turns on and off. So the duty cycle of the compressor is 40%. Now you are required to calculate its units and bill for a month. So can all of you just start with this calculation? Just try it out. So we have 4 by 9 watt LED, and it is on for 10 hours. The next one is 2 by 60 watt fan, and that is on for 16 hours. One TV with rating of 100 watts, on for 5 hours. And then finally we have one refrigerator which is 200 watts and duty cycle of 40%. What we need to do first is to find watt hours for each. So for each element we need to find watt hours. And then add them together, right? From there we'll move on to multiplying it with the cost per unit. So let's just switch over the camera. All of you have taken this down? So for those of you who have already got this down, what is the watt hour for the first item, which is the LED bulb? Any guesses? Watt hours. So we have 4 9-watt LEDs for 10 hours. 360. Yeah, 360 for the first one. The second one, 120 times 16 hours. Yeah, 1920. This is 500, third one. The final one, anyone? We multiply it for 24 hours and then take 40% of that. Let me just switch to the camera. Okay. So for number 1, 4 times 9 times 10. Okay, we get 360 watt hours. All right. Let me just write the units down just to avoid confusion. So this is 4 times 9 watts times 10 hours. So that comes to 360 watt hours. The second one, 2 times 60 watts times 16 hours, which is 1920 watt hours. Third one is 100 watt times 5 hours, which is 500 watt hours. Finally, we have a refrigerator, so that's 200 watt times 0.4 times the 24 hours, okay, which is, okay, we can round it off to 2000. Now we add them together. So 360 watt hours plus 1920 watt hours plus 500 watt hours plus 2000 watt hours. Any answers? 4780. Now we can convert this to kilowatt hours, yes, which is equal to 4.78. Now this term might be familiar to you, kilowatt hours. So from kilowatt hours we can find what would be the electricity bill for Fiji. What is the charge per kilowatt? 34 cents, yes. So we multiply this by 34 cents. So the bill will be 4.78 times, oh, I think I made a mistake here. I need to multiply it by 30. Before this step, this is per day, right? So 4.78 kilowatt hours times how many days in a month? We can just take 30 for now. This will, what do you get? $143.4 kilowatt hours. So let me just cross this off. So we have 143.4 kilowatt hour times 0.34. Okay, converting the 34 cents to dollar. What is the bill? Yeah. $48.76, okay, for this particular month. Okay, let me say bill for the month. So all of you have been doing this calculation when you look at the bill of your place. So you are familiar with this. All right. So let's go back to the computer. Okay, how to get or obtain the maximum demand? Okay, there are 4 ways. The first one is calculation, which we'll be looking at later, and we also follow the Australia and New Zealand standard. So we will be using this Australia and New Zealand standard 3000, all right, to calculate the maximum demand. The other 3 for the as per this course, it is we are not going to cover this. Okay, the assessment, measurement, and limitation. But we can have a look at the definitions. So the assessment for MD, okay, the assessment is done for these particular places. Okay, not for all areas or for all supplies. Only for these 3 components. For example, the electrical equipment operates under conditions of fluctuating or intermittent loading or definite duty cycle, or the electrical installation is large and complex, or special type of occupancy exists. Okay, this is in these places we have assessment. For measurement, we use something called the maximum demand recorder. Okay, anyone has done the attachment at EFL? I don't think you have done any attachments at the moment, right? So the MD is measured, and how it is measured? For any household or any occupancy, the maximum load that is sustained for at least 30 minutes in a month. Okay, if it is less than 30 minutes, that means that is not the maximum demand. But if a load is sustained for 30 minutes, then that can be classified as the maximum demand by the maximum demand recorder. Okay, so the consumption is sustained for 30 minutes, a particular demand, that means that is the maximum demand. And the last method for finding the maximum demand is by using the current rating of a fixed circuit setting of a circuit breaker, okay, or load setting of an adjustable circuit breaker. So the circuit breaker also at your homes, through that we know that for each home what would be the maximum demand, right? Now to do the calculations, okay, the first method that we have seen here, Australian New Zealand standard, we will be using the table C1. So it provides allocation for the different types of loads and equipments connected to the consumer mains. Okay, and using that the current for each can be calculated. Okay, let me show you the table C1. Now the label of table C1 I have used the same as what is in the book. All right. So this is what table C1 looks like. Let me download it. Okay, so we have the load groups here, the first column. The second column is for single domestic electrical installation or individual living unit phase. So we have individual unit here, and then third, fourth and fifth are the blocks of living units. So we can have 2 to 5 living units per phase. Okay, so this is per phase. All right, we don't use 3 phase in our homes. Okay, so per phase we will have one single unit. The third one is from 2 to 5 units per phase. The fourth one is 6 to 20, and the final one is 21 or more units per phase. Right? You guys understand what unit is? Unit is the particular, for example, a home. Okay, and this can be 2 to 5 flats, 6 to 20 flats, 21 flats or more. All right. And for the load group, the group A is lighting. The group B is all the socket outlets for 10 amps, 15 amps, okay, or 20 amps. And then we will have to, for each load, if you are given a problem, we will first need to find out the number of points. From the points, then we add the points and then find the maximum demand. Right. So if a question is given for a single domestic installation, we will use this column, or depending on then the number of units, then we will use it for multiple units, you will use the other columns. Okay. So continuing with the load group, B was our socket outlets, C is our ranges, cooking appliances, laundry equipment, or socket outlets rated at more than 10 amps for the connection thereof. Anyone knows what ranges are? There are those with cooktops and oven beneath it. You must have seen in the restaurants a big bulky cooking appliance. Part D is heating and air conditioning. Okay. E is the instantaneous water heaters. F is storage water heaters. G is spa, swimming pool heaters. H is communal lighting, and communal lighting is something that is shared by a community, right? Now, group I has socket outlet which are not already included in the loads of J and M. And as you can see the small numbers here. Okay, there are notes which you will find at the bottom here, notes to table C1. Okay. So load group J has 3 or 4 parts. J is composed of appliances rated at more than 10 amps and socket outlets for the connection thereof. So we have these connections here. Okay, clothes dryers, water heaters, self-heating washing machine, wash boilers, right? K is lifts, I is motors, and M is other appliances which are not included from A to I above. This can be something like X-ray equipment and so forth, which are not commonly found in domestic installation. Okay. So when we look at an example, then you will get a fair idea of how to use the table. So we will be doing that now. Okay, so we are supposed to find the maximum demand of a single domestic electrical installation supplied at single phase with a falling load. So we know this is a single domestic electrical installation. That means we will be following the column 2. Okay, and for that single phase, these loads are connected, 24 lighting points, 10 meter of lighting track. What is the lighting track? Okay, lighting track, that is you must have seen this, usually used for decoration, okay, which has light running across in a line. Okay, and then we have 9 by 10 amp socket outlets, and then 8 by 10 amp double socket outlets, 1 by 50 watt exhaust fan, a 1000 watt strip heater. Now this strip heater is not an instantaneous nor a storage. Okay. The other one is the 1 by 15 amp socket outlet, and then we have 1000 watt range. Now this one water heater, if you see what how it is written, right, water heater here means the storage water heater. Okay, 4800 watt water heater, and then we have 3000 watt tennis court lighting. So what I'll ask you guys to do is just copy this down and try to map them into their groups. Okay. First one, 24 lighting points. So all of you got the list? 24 lighting points. I can tell you that it will fall either in group A or group B. Okay, no need to go any further. We have group A is lighting. Now there is this table is exactly from what was in the Australian New Zealand Standard 3000. You will see that this doesn't make much sense. Okay, lighting. So part 1 is lighting except part 2 and load group H below. And again there is part 2 here, outdoor lighting exceeding a total of 1000 watts. So this actually should be lighting except load group H below. Load group H is here, communal lighting, right? But we don't worry that much on that, because we know that lighting for any lighting points will obviously fall in this group, okay, except when it is in a communal lighting or outdoor lighting, then we have to decide on that. But any lighting point inside the house will just fall into group A, part 1. Okay. So we can just label it as this is group A1. The next one was 10 meter of lighting track. Now 10 meter of lighting track. Okay, it's not outdoor lighting, so it will fall into group A1. Okay. So again group A, part 1. The next one is 9 by 10 amps single socket outlets. Alright, so single socket outlet, now we will see in group B. Part 1 is single outlets not exceeding 10 amps. Alright, so you can see our load here is 9 by 10 amps single, so most likely we can see it will fall into group B1. Group B2 is for 15 amps, so we don't have to go there. 20 amps we also don't need that, so this will be in group B1. The next one is 8 by 10 amp double socket outlets. What about this one? Anyone? Same? Yeah, because it's still the 10 amps, okay, even though it's double, but each of them have 10 amps. So this will be group B1. The next one is 1 by 50 watt exhaust fan. So that will not fall. Okay, we have to look further, okay, where it will most likely fit in. Doesn't fit in this load group, okay, cooking appliance and laundry equipment or socket outlets rated at more than 10 amps. If we calculate the current of this 50 watt, what will we get? Exhaust fan is 50 watts. So if we divide 50, what is the current that we get? Power is equal to VI, so current will be power divided by the power 50 divided by 240. So it's nowhere close to 10 amps, right? It is not a fixed heating or air conditioning equipment, so we can skip that again. Not a water heater, not storage heater, doesn't fall in the spa or swimming pool, not in the lighting, not even in the group I. Again, J is rated more than 10 amps, right? Doesn't fall in K. I, nope. What about group M? Do you think this will fall into group M? It looks like it will fall in this group, right? But if you go through the, so it will take you some time just to see where each of the load can fit in. All right. If we see a note here, note 5, okay, an appliance rated not more than 150 watts, okay, which is permanently connected or connected by means of a socket outlet installed more than 2.3 meters above a floor. So this is an exhaust fan that is connected at a height, so it's obviously would be close to the roof, so it must be more than 2.3 meters, may be included as a lighting point in load group A, right? So for any appliance which is rated not more than 150, we add it in group AI, okay, A1 you can say. So we can write this as group A1, okay. Let me just add C note 5 of table C1. Next one is 1/1000 watt strip heater. Before we go into the look up the table, if we calculate the current of this 1000 watt divided by 240, the current we get for this one is 4.17. All right, so we just make sure we have the current calculation, and then Let's go back here. Okay, we can skip the first page. Load groups A and B, C, no, D, no. E, what about the instantaneous water heaters? Okay, the trick is, if instantaneous is not included, you don't include it in this group. Alright. Storage water heaters, if it is specifically says water heater, then it would be storage. If it says instantaneous, then only it will be in this group E. Alright. Now for this strip heater, you guys, let me just show you what strip heater is. Okay, water comes in and then it heats when it runs along this connection. Okay, it uses surface area to transfer heat. Alright. So it is a water heater, but it doesn't fall into instantaneous and storage water heaters. Okay, it's a small device. Furthermore, if we go into the other load groups, it doesn't fall into J because the current rating is obviously less than 10 amps. Lifts, motors, no. Appliance, no. So only thing it was closed was to the water heaters, which will, and then we know that this will not fall into either of these groups. Now when we read through these notes here, okay, and we come across note 9, each item of permanently connected electrical equipment not exceeding 10 amps may be included in load group B1 as an additional point. Right. So using this note 9, we can say that the strip heater falls into the group B1. Okay. One other thing to differentiate it from instantaneous water heaters. Okay, for instantaneous water heater, you can see the note 12 here. You guys can see. What is note 12? Instantaneous water heaters including quick recovery heaters having element rating greater than 100 watts per liter. Now, do we see this unit in our strip heater? No. So this would be a good indicator that it is not a instantaneous water heater. We don't have this unit here. Okay, watts per liter. So there, instantaneous water heater cancels off, and it is also not a storage, because as is seen in the diagram or the image, it is not a storage water heater. So we can say this falls to group B1. Okay, I think we'll just have a look at one more item. Oh, I think we just stop here, and then we look at the remaining load. We try to classify them, and then we'll carry out the maximum demand by finding the current, the maximum current for this load. Okay. Okay, short test, most likely I will push it to week 7. Yeah, Friday. So let's keep the date as Friday week 7. But if anything comes up, if the changes is a change in the time, then I'll let you know, change in day and time. Week 8, I'll let you know if week 7. Because according to the Dean Learning and Teaching, we should have our short test assessment by before mid-semester break. But I have to check on that if we can have it in week 8. You guys have completed the lab? Not yet. What is the difficult part? I mean, which in the lab report writing format or? Okay. By how, what value does it exceed the illuminance level? Is and the required is 750. 760. Okay. So the particular light that you choose, what happens if you use different lights? Have you